Hello everybody. I want to show you my new circuit, and I put the neo magnets on the motor, so I'm going to actually start making everything a little bit smaller, more compact. But I wanted to show you guys something on how the cap feeds back the coil circuit. So on the counter EMF is being fed into this cap when the pulse collapses, and then when it needs energy, the cap shoots it back into the coil. And I'll show you how significant that is. Let me just get this started. Bear with me, I got to get the timing down and stuff like that. I want to show you the startup amps and stuff. You can hear it when I adjust the timing, how it smooths out. And I'll tell you why it's so bumpy, because I have a kind of a rickety setup here for my coil. Let me get this up to speed here. All I'm doing is adjusting the timing on the reed switch and the coil so I can get that sweet spot. Okay. See, the amps are reading about, looks like 150 milliamps. We can get that down a little bit by just adjusting the timing. Now it's reading at about 100 milliamps. Okay, 12 volts, 100 milliamps. You guys do the math on that. About 1.2 watts. Now I'm going to show you my setup here. Don't laugh, I had to make a little tower for this deal. Okay, see how the coil's there? When I move the coil, I get more speed out of it, but since it's rumbling around so much, I have to lock that coil in place. I had to make that because it wouldn't go underneath here anymore, because the neodymium magnets are just way too strong. And you can see how much brighter that light bulb is. That sucker is very bright. I'm not going to show you the readings on that now, but it's about 9 volts and 200 milliamps. So I'm getting about 1.8 watts off of the secondary coil. And the alternator, of course, is still cranking away. You can hear from my last videos that the neodymium magnets are definitely giving this thing a lot more torque. Now watch what happens when I take off the secondary lead. This is on the 26 gauge coil on the bifiller. Listen to what happens. The motor starts to slow down because it's actually doing double work. If you don't pull that electricity off of there, the motor starts running against itself. It's a motor and a generator. So if you don't pull off the generator part of the electricity, the motor starts working against itself. Okay? The same goes for the counter EMF. And I got rid of the bridge rectifiers, and I'm just using a rectifying diode. And all I'm doing, let me show you. See that red lead right there? That is going to the cap over here and the amp meter. Okay, showing you guys the true amps on this. The green lead right there is going to, of course, the negative part of the battery to make the motor run, and to this rectifying diode and the cap, the other end of the cap. Now I want you guys to see what happens. See that the amps are actually down now. Amps are maybe 80 milliamps now that this thing is cruising. I want you to see what happens when I pull off the counter EMF off the cap. Look at those amps climb. That's at about 200 milliamps, maybe 250. So what's happening is the capacitor now has electricity stored, so instead of using just full battery power, it's using some of the power in this cap. So I need to get a bigger cap because it's using all the power in the cap. When I short out the cap or put it through a little light bulb here, I get no light whatsoever off of this. None. That means it's using all the power in the cap. So I need a big cap. Big cap. Big cap right here. So I'll even be using less from the battery, and what I can do, well, I just wanted to say goodbye. Sorry I was interrupted there. Anyway, I need a big cap, and that way I can get a big cap on the back end and maybe get this thing self-running. So that's the update for now, guys, and thanks for watching. Talk to you later. Bye.